Hello everyone, this is going to be a quick screencast of how to get your data in and put error bars on your G on an incline lab. So the first thing I've done is I've recorded the heights of the ramps that I used and the accelerations that I got down that ramp. And real quick, I'm going to show you how you can make this not just be X and Y, but instead actually have your labels and your units on them. So if I double click right here, I can change this to a name that would make sense for me. We'll use height, and my short name will be H. And I can give this a unit of meters. And you can see if I come over to options, it's going to give me an option to put error bars on that. And there is an uncertainty in height. We know that my uncertainty is a millimeter. So I'm going to go ahead and say 0.001 as my uncertainty, and I can say done. Now when I look back at my height, if you see here, if this height is going to be in meters, it becomes rather obvious that I did not measure this in meters. It looks like me and my lab partner must have measured this in centimeters. So what I really should do is come back and change all of these to meters. So I'm going to do that real quick just by clicking on this and saying 0.0. That would be converting that to meters, and don't want to double click, just click once. There we go. And this would be, oh my goodness, there we go. 0.0, get rid of that second decimal because it will not be happy about that. And so on, so you can see that 0.0142. Let's do 0.0. Get rid of that second decimal. And I saw quite a few people when I was going through the labs that weren't handed in yet who did have heights recorded in centimeters. At least it looked like you did. So you might just want to do a check and make sure that your units match up with what you really did. And I can even see right here that that doesn't make sense. I don't want a 0 there. Don't make the same mistakes I'm making. And there we go. Now I have heights that actually make sense, and I have corresponding accelerations for them. I can then double click on my Y column, and I can go back to column definitions and give this a name. We'll call it acceleration, except there's an L in that, and we'll give this A. This is going to be in meters per second. You can see when you look at your drop-down menu right here, you have superscripts. And so I'm just going to do meters seconds to the -2, because that would be meters per second squared. That is not how you spell acceleration. We're just going to do that for short. I can go over here and I could put error bars on this. Now, I originally did not ask you guys to put error bars on this, but if you did, you can think back to the last time that we did uncertainty and acceleration. Remember, we were dropping that picket fence. Your average uncertainty for acceleration on your LabQuest is going to be about 0.1 meters per second squared. So I'm going to go ahead and put that in there, and I'm going to say done. And now you can see that it reformatted everything, and I can barely see what's going on. Well, you can always come right up here and click this auto scale button, and now I have a nice picture of what's going on. And let's say I didn't want this so close to the axis. We can actually come down here and drag this around and resize our graph to whatever makes us happy. And I actually kind of like that right there. So now what I have is height on my x-axis, acceleration on my y-axis, but what I want is acceleration and sine theta. So what I'm going to do is make a new calculated column that's going to take those height measurements and turn them into a sine theta measurement. And in order to do that, I'm going to go to Data up at the top and say New Calculated Column, just like that. This new calculated column is going to be sine theta. And if you come to the drop-down menu, you can see they have Greek lowercase and uppercase letters, so I can actually choose sine theta. That is actually a rather short name, so I'm just going to copy and paste it right down to my short name. Now there are no units in sine theta. That is a ratio of 2 lengths, so it would be unitless. And the ratio is going to be the height divided by the length. The length that I measured was 122, or 1.22 meters. And that really is just opposite over adjacent when I'm calculating out my sine theta. So I can say done. And you can see I now have a sine theta column, which is great, and I want that to be on my x-axis, so there we go. So I'm getting something that's looking a little more like what I'm looking for. What I wanted, though, is for you to give me the uncertainty in sine theta. And you can see if I come up over here and double click on sine theta again, this is what we define the column as. I can go over to options, and I can calculate out some error bars. But the error bar is going to be a function of the percent uncertainty in the height and the percent uncertainty in the length. I have to add those together. That's the percent uncertainty in sine theta. So I can't just put in a constant. I actually have to calculate that out. And so in order to do that, I'm going to make a new calculated column. Over here on the data menu again, I go to new calculated column, and I'm going to call this the uncertainty in sine theta again. And I'm going to use a Greek lowercase. My short name for that is just going to be US. Again, there's no units on this because the units on the uncertainty is going to be the same as the units on the value, and sine theta is a ratio of two lengths. Now, when I'm looking to get the uncertainty in the height, that's going to be 0.001 divided by the height to get it into a percent uncertainty. Now, if I really wanted to put this into a percent, I'd multiply by 100, but I'm going to use this to calculate the percent in sine theta, so that's just going to make me divide by 100 again, which is going to make my life harder. So we're just going to say that right there is the percent uncertainty without multiplying by 100 for the height value. We're going to add that to the percent uncertainty for the length, which is going to be 1 millimeter. Divided by 122 because that said that's what the length was. Of course, you could just put that in as one value. Oop, that should be 0.001. You could just put that in as one value. I'm just going to put it out so you know how I calculated it. Now, I'm going to take this whole thing right here, which is the percent uncertainty in sine theta, and I'm going to multiply it by sine theta because that'll give me the absolute uncertainty in sine theta. Now, can everyone see that not only did I put no spaces between here, because it will get confused if you put spaces, I was also really clear with my orders of operations. I put parentheses around everything to make sure it knew what order I wanted everything done in. So I can say done, and I can have an uncertainty of sine theta calculated right out, and it does end up that it's exactly the same for everything for me, which is perfectly fine. So I'm going to come back over here to my sine theta column, and I'm going to go back over to the uncertainties, and I'm going to go to error bar calculations. And rather than using a constant, even though I know it ended up being the same for us, I'm going to say use a column. And I'm going to choose that I'd like to use the column that was the uncertainty of sine theta. And I'm going to say done. And you can see that there are teeny tiny error bars on my sine theta that you can barely see because there's really not much at all. And that is not an issue. I knew it was going to be really small. So the last thing I have to do now with this graph is do a check and make sure that all my numbers make sense. I'm going to do a linear fit, and my linear fit says the slope of this is 9.810 because I was incredibly careful when I took my lab data. You can see, though, that this doesn't quite make sense because I can't see 0 in here. So I'm just going to move this until I get 0 on my graph. I just like to see that. It gives me kind of a frame of reference for what's going on. There we go. So I have 0 on my graph now. I have this right here. And now this all looks pretty good. So my last thing to do is take a screenshot. Depending if you're on a Mac or a PC, it's done a little bit differently. I'm on a Mac, so I just hit Shift Control Command 4 all at the same time. I drag my little crosshair that it created to what I want to take a screenshot of, and I'd like a screenshot of this graph that I made. I'm going to then go over to the Google Doc that we've been putting all our answers in, and I'm just going to paste this graph into the bottom of it. Now, as soon as I put my free body diagram in, I am done with my lab. So this should be, I'm hoping, enough information for everyone to do the Logger Pro graph. I want everyone to get that done by Sunday evening because it is due at 7 a.m. on Monday. And you should not be staying up to 7 a.m. to do that, because you can see it really didn't take me more than maybe, 10 minutes to get this done. So everyone have a lovely weekend, and I will see you on